Today, we will talk about time zones and the Coordinated Universal Time. So before looking at these concepts, we have to see how time is measured. On Earth, the passage of time is measured by the movement of the sun in the sky. Although in fact, it is the rotation of the Earth around its own axis that produces the effect that the sun moves in the sky. With this in mind, the Earth makes one complete revolution around its own axis in approximately 24 hours, and that period of time is what is considered a day. Now, the current time of day depends on our position on Earth. As we can see in this example, the sun always shines on one side of the Earth, while the other side remains in darkness. In this case, we can see the line that divides both sides, which is the sunrise. This way, in the north coast of Colombia for example it is 3 a.m., while at the same time, on the west coast of Africa it is 9 a.m., and on the east coast it is noon. Taking this into account, we can say that each position on Earth will have a specific solar time, depending on the relative position of the sun in the sky. Now, the solar time is the real time relative to the position of the sun and an observer at a point on the Earth's surface. One important thing to bear in mind is that points on the same meridian will have the same solar time. So in other words, we can say that solar time depends on longitude. So let's relate the degrees, minutes, and seconds of longitude to the passage of time in terms of hours and minutes. As we already mentioned, the Earth makes one complete revolution around its own axis in 24 hours. So we can say that it rotates 360 degrees in 24 hours. This means that it takes 1 hour for the Earth to rotate 15 degrees. And therefore it takes 4 minutes for the Earth to rotate 1 degree, and 4 seconds to rotate 1 minute of longitude. With this being said, to know if it is later or earlier at a point on the Earth with respect to our position, we must take into account that the Earth rotates from west to east. This way, in all places east of our position it will be later, while in places west of our position it will be earlier. We can see this more clearly in this example. Here we have the lines that represent noon, sunrise and sunset. So let's say that we are in this yellow point in Africa, and as we can see currently it is noon. From this perspective it is more obvious that in all places to the east of our position it will be later, while in all places to the west it will be earlier. Now, the question is, how early or how late is it at a certain point on the Earth with respect to our position? Well, it is possible to calculate how different the solar time is between 2 points by knowing their longitude. Let's see the following example. Here we have the coordinates for the cities of Miami and Berlin. So the question is, if the solar time in Miami is 4 a.m., what solar time will it be in Berlin? Well, first we have to determine the difference in longitude, which is the distance between the meridian that passes through Miami and the meridian that passes through Berlin, in terms of degrees, minutes, and seconds of arc. So as we can see, Miami is 80 degrees and 11 minutes west of the prime meridian, while Berlin is 13 degrees and 24 minutes to the east. Now, since the points are on different hemispheres, we must add the longitudes to obtain the difference in longitude, which in this case is 93 degrees and 35 minutes. Now that we have the difference in longitude, we must convert it to time. So as we previously mentioned, 1 degree of arc corresponds to 4 minutes of time, and 1 minute corresponds to 4 seconds of time. In this order of ideas, 93 degrees equals to 372 minutes of time, and 35 minutes is equal to 140 seconds of time. If we express it correctly, it would be 6 hours 12 minutes and 2 minutes 20 seconds. This way, the total difference in solar time between Miami and Berlin is 6 hours, 14 minutes, and 20 seconds. Now that we know the difference in solar time between these cities, it must be determined whether to add or subtract the time difference, depending on the relative positions of the cities. As mentioned before, in all places to the east it will be later, and in all places to the west it will be earlier. This means that if the city is to the west we have to subtract the time difference, while if the city is to the east we have to add the time difference. In this case, since we have to determine the solar time in Berlin, which is to the east of Miami, we have to add the time difference, obtaining the current solar time in Berlin, which is 10 a.m. 14 minutes and 20 seconds. With this method, it is possible to determine the difference in solar time between any 2 points on the Earth, which implies that whenever there is a difference in longitude, however small, there will also be a difference in solar time. This includes cities within the same country, or even within the same province. Here, for example, we can see the coordinates of Quito and Guayaquil, which are two cities in Ecuador, which is a small country in South America. So let's determine the difference in solar time between these cities. Here, since both points are on the same hemisphere, we have to subtract the longitudes to obtain the difference in longitude, which is 1 degree and 32 minutes. Then we convert this into time, obtaining a difference in solar time of 6 minutes and 8 seconds. So this implies that if, for example, the solar time in Quito is 8 a.m., we must subtract the time difference, since Guayaquil is to the west, obtaining the current solar time of 7 a.m. 53 minutes and 52 seconds. As we can infer, having time differences between nearby cities is a big problem to establish schedules and coordinate operations, so in order to standardize the same time in a certain area, time zones were created. So, for reasons of convenience and standardization, it was decided that the Earth would be divided into 24 time zones, each 15 degrees wide, and as we know 15 degrees equals to 1 hour, so each time zone differs by 1 hour. This way, the total width of each time zone is 15 degrees, which means that it extends 7 degrees and 30 minutes to either side of its central meridian. Now, each time zone adopts the solar time of its central meridian. This way, all countries and territories within the same time zone will assume the same standard time, which means that they are no longer based on their actual solar time. Now, this standardized time for each time zone is known as local mean time, and is usually abbreviated as LMT or only LT. In this example, the local time for countries within this time zone will adopt the actual solar time of the 75 degrees west meridian. However, in some cases the countries are so large that they may have more than one time zone. A clear example of this is the contiguous United States, which have 4 time zones, and as we can see, the lines that divide each time zone are not always straight, since they adapt to territorial limits and borders. And this not only happens in the US, it actually happens worldwide, since governments have made arrangements to modify time zones to coincide with border or territorial boundaries, as we can see here. Now, there are several ways of naming the different time zones. We can use the number of its central meridian, for example, 60 degrees west meridian time. We can also use letters from A to Z, excluding the J, for example, the Z time or Zulu time. And finally, we can use the position of the time zone relative to the prime meridian time zone, for example, UTC +5. Here we can see how the different time zones are named based on these methods. Let's now talk about the Coordinated Universal Time, which is abbreviated as UTC. This is the international time used as reference in air operations, and it corresponds to the local mean time of the prime meridian. Another names for this UTC time are GMT, which stands for Greenwich Mean Time, and Zulu time, which represents the time zone Z. However, in practice, they all refer to the same time, so they can be used indistinctively. Now, the use of the Coordinated Universal Time greatly facilitates coordination and commerce, especially on long flights where several time zones are crossed. And also by using UTC, everyone can be sure that they are referring to the same exact time, without having to make conversions and calculations, which results pretty useful for flight plans, NOTAMs, radio communications, and many other aviation applications. Now, an important time to keep in mind is the time of sunrise and sunset for a specific airport, since some air operations are limited to daytime. In this case, although the local time of the time zone is used as reference, The actual solar time at which sunrise and sunset occur at that specific position is taken into account. And it is also important to bear in mind that at the same airport, the sun will rise and set at different local times throughout the year. This is why the Civil Aviation Authority of each state shall publish official tables with sunrise and sunset times for each aerodrome throughout the year, as we can see here. These times will determine the boundary between what is considered daytime and nighttime operation. I hope the information presented in this video was useful. If so, don't forget to share, like, subscribe, and leave a comment down below. Thanks for watching.